the communities, the international community and the national communities, where you can meet fellow teachers and share your experiences on environmental and geographic education. You have the e-modules, which are online courses on several topics related to the geo topics that GEO-Academy has prepared. You have some sessions on events and news. And particularly for this presentation today, we are going to explore the e-modules related to robotics and coding. More of that in a minute. In order to access the e-modules, you need to register for the platform. So if you visit the portal, you have the login option on the right. And when you click in login, you'll be directed to this screen. So this screen, if you already have an account, just enter your username and password. But if you don't have an account, you need to register. So you need to select register to create your account, and that will bring up the registration screen where you need to fill your personal details and create your account. After you create your account, you will receive a confirmation email, and then you will be able to access the full content of the GEOBSERVE platform. One important note is that you need to have your cookies active for accessing the portal. Otherwise, you won't be able to complete the registration. So please accept all cookies. If you, by mistake, you reject cookies, you can scroll down up to the bottom of the page. And here, if you click on cookie policy, you'll be asked again if you want to accept the cookies, and please do so. Also, you need to click on this captcha here by the end to confirm the registration. If you don't see this button, please accept cookies and reload, and you will be able to register. So after you complete your registration and login, you can access the full content. So now here I'm logged in my account. And what we are interested today are the activities related to the GeoKit, which we will show very briefly in a moment. So these are all concentrated here in the GeoHubs section of the GeoBserve platform. If we go here on GeoHubs, you see a map of the different geotopics that are related to the different courses and activities. It's a bit slow here, but eventually we will see. It's not the GeoHubs, sorry, it's the e-modules. The GeoHubs are the communities, sorry by my mistake, but here you can find the GeoHubs, the different national communities, and in the e-module sections, you will have a menu of different geotopics that will lead us to the specific courses. So today, as we are talking about the GeoKit, we will be using this geotopic, which is coding for urban sustainability. And here, if you click on that button, we have here 10 different courses that you can use to explore this geotopic. In particular, we have some topics here, there's some courses that use the GeoKit. So after we show the GeoKit, we are going to explore more closely this activity here, this course, which is building a seismometer. But right now, I'd like to ask Luis to help me in presenting the components of the GeoKit. So Shana, if you can pin the other camera, is it working, Luis?
Yeah.
Yes, okay. So the GeoKit was prepared by the GEO-Academy Consortium, and it includes several sensors and microcontrollers that will allow your students to collect data and learn more about environmental topics, and also related to the special locations where this data is collected. So it's a very powerful tool to have some interesting experiments in the classroom, and also promote learning coding, because to have this microcontrollers working, you need to code them. So on the bottom row that Luis is showing now, we have two different types of controllers that we use. The first one is the Arduino, which is very well known. So we have some sensors that will work with the Arduino. And by the side, we have each GeoKit has two microbit controllers. And today in the activity, we'll be using both at the same time. So this is a different type of microcontroller, the microbit, which is very versatile and very easy to use. So in the GeoKit, you have, therefore, three microcontrollers, one Arduino and two microbits. The microbits, they come with the cables to connect and also the power pack that allows the use of the microbit uh, away from the computer. So it's the power source. There, Luis is showing the connection cables, the standard USB connections for Arduino and for the microbit. And now here on the bottom right, we have the expansion modules. So we have two expansion modules for the microbit that allows integrating the sensors and the other components in Arduino and in microbit. Now, moving up to the next row, we have this. This is a case of the microbit, where for the packaging, we'll see also the batteries, because the microbit can operate with batteries. And you also, can you show please again, there's an electric motor with a cord, and you soon you know why there's an electric motor and a cord incorporated in the GeoKit. Now moving to your left, Luis, we have another power source that comes with on and off button. And we have the power pack for the Arduino, plus the cables that he already showed. And on the top row, we have the sensors. So we have different type of sensors. This one, I think, is the GPS module, right? Then we have the temperature sensor and humidity. There's the gas sensor. We also have a display module for for LED sensors for the, I think that's for the Arduino. And finally, we have the breadboard that is to connect the different elements, plus several jumpers and resistors that are used to build the circuits. So everything comes inside a small plastic box, and each partner in GEO-Academy received such a GeoKit, and this is being used in the schools that where the teachers that participated in our trainings, they learned how to use this GeoKit and how to use it in their classes. So today, what we are going to use, and if you can already pick up the components, we use the two microbit sensors in the activity that for the seismometer. So why do we are using two? Because one will be the sensor itself that will collect the movement of the sensor to simulate if there's an earthquake, it will shake, and we'll register the movement, and we'll send the data to the second microbit, which is the receiver. And the receiver will transfer the information to the computer, and we can have real-time information about the shaking of the sensor. So this is going to be our activity, but before that, I'm going to talk very briefly about the other activities. So this is a very simple experiment that only needs two microbit sensors. So if your school already have these microbits, you can immediately start using this lesson plan, because you don't need the other components. But if you want to do the more sophisticated use of the GeoKit, then you need all those extra sensors that we presented, and this is explored in depth in the other activities. Okay, so thank you, Luis, for being my cameraman. I'll go back to the presentation. I'm still sharing, right? So let's now go back to the portal. So I started here, so we are going to explore this activity in a moment. But we have other activities that use the GeoKit. So this one, for instance, is a very interesting activity that is related to the air quality. So most of us live in urban areas and we have lots of pollutions from industries, from vehicles. So it's an interesting project for the students to monitor themselves, the air pollution, and this activity explains how you can use those sensors with your Arduino controller to have your own environmental air quality station. We have these other four activities that uses, this one uses the GPS module on your Arduino sensor or even on your phone, and how you can use the sensors to create a petty paper adventure, which is very popular with students, especially young ones. This is another interesting activity that touches the subject of sonification. That is how you represent data using sound. So both the Arduino and the microbit, they have speakers that can emit sounds, and then you can uh, use the sensors to collect the data and the processor to uh, have the output of this data in form of sound. So this process is called sonification. And it's very interesting, not only for having the representation in different formats, but also it's very inclusive because people who are visually impaired, they can now receive this information via sound and not via images as is usual. We have two more activities that were developed by Luis. One is about also climate monitoring. So we can use, for instance, the temperature and humidity sensor to and relate this to agriculture. And finally, an activity that's about lighting efficiency. So this is very important these days, facing the environmental crisis that we are living in. We should be conscious about the use of energy, and this activity will address exactly how you can have a more sustainable way of lighting our living places and our offices. So these are the activities that use the GeoKit. There will be a few more coming before the end of the project. And you can explore them all in the e-module section of the GeoBServe portal. That being said, we are going to explore now in detail the building a seismometer activity. So this is a course, so you need to enroll the course. I'm already enrolled. So after you create your account, you log in on GeoBServe, you can go to the e-module, select the building a seismometer activity in the robotics GeoConcept, enroll it, and then you have here an overview of the course. You have the curriculum, and you have the materials. So in the curriculum is the index of the activities. So it is divided in two parts. We have a pedagogical component that is to help the teachers to to start this activity with the students, depending on the age of the students and also how much time the teacher has. And in materials, you can find the technical reference guide, which is the step-by-step guide on how to assemble that particular experiment and have it working on your computer. So that's what I'm going to show immediately now. So you can download the technical reference document and open on your own computer and check how you can have a seismometer in with the microbits. So we are going to use the microbit sensors, and if you never use it, these sensors, these controllers, I highly recommend it because they are very versatile, very easy to use, and the students, they love to work with it because it's so easy, and there are so many things that you can do it. And the most interesting part is that you don't even need a microbit to start learning about it, because uh, this is a product that is related to Microsoft, and you have, if you go to the main website, which is makecodes.microbit.org, you can emulate the microcontroller in your own computer. So how does it work? It works when you go to makecodes.microbit.org, you can create an account and you can immediately start working with the projects. So I'm going now to, so how you do it? You just go to sign in. You can create an account with your email, if you have a Microsoft account, or if you have a Google account, you can sign up. I already have an account, so I'm going to just use my Google account to continue using the Make Code platform. And how does it work? So the microbit, the microcontroller, it doesn't have any keyboard, it doesn't have a display. So it's very powerful, but you have to code in your computer, and when the code is ready, you transfer the code to the sensor. So that's how it works. And for this particular project, we need two codes. One code that for the sender, which is the sensor that will record the shaking, and another code for the receiver that will be on the connected to your computer in receiving the data. So you need to write two codes. Okay, and I already did that, but before going in that direction, I'm going to stop sharing and showing a step-by-step guide on how to do it. So meanwhile, Shana, Lucas, are there any questions from the audience, or should we continue? We can continue, right?
We
We
can
can
continue, yeah.
continue. Yes.
Okay, so I see Aphrodite is here. Hello, Aphrodite. So, okay, so I'm going to now change presentations so we can see a step-by-step guide. Again, this is all available on the GEOBSERVE platform in the course that I just showed. Oh, I need to share again. It's always, okay, so where is it? Okay, I'm going to show you two things actually. So this thing here, what is it? Is the component list. So you will find on our website the component list for the GeoKit. So if you want to have a similar kit in your school, you can just purchase the same components. Maybe you have most of these elements already in your school. So GEO-Academy has this available for you. So you can have a similar kit in your school. And I'm going to share now again the activity itself, the activity guide, which is here. It's one, it is winter school, exactly. So this is the one that I want to show you. So this was an activity that we developed for the winter school that took place in Vienna early last year. So what we're going to use from the GeoKit, the hardware is very simple. We have the two sensors that I already mentioned. We need two battery packs. One is to power the sender because it will be elsewhere. And the other one is to power the electric motor that will produce different vibrations. So this number 5 here is very similar to number 4. The difference is it has a on-off switch that you can use to turn the motor on and off. There's also a cork. This is to dump the vibrations, and you can try different geometries of the cork connected to the axis of the electric motor. And you have an USB cable that you'll be using to connect the receiver to the computer where you see the data collected by the sender. So how do you work it? You go to your Make Code account and you select new project. The first project that we'll code is very simple and is the sender code. Just let me just close here the thumbnails. No, it didn't work, but no problem. Okay, just want to. So we go to make code. You select a new project, and you are going to name this project sender. And in microbit and make code, you can code in different ways. If you know how to code, you can code directly in Python, or you can code in Java. But the easiest way, especially with students, is to use this visual type of coding. It's block coding. And you have on the left side of the coding different types of functions. What we have here, I'm going to do it step by step very shortly, is that we need to code the sender program to use its radio capabilities to record the movement and send the information by radio to the receiver. So we have two blocks of coding, and that's I'm going to show now the code itself on my account. I need to stop sharing again. Sorry, but I need to go back and forth the different windows. So now going back to the Microsoft Maker code. So let's have a look at the sender so we can check how it looks. So this is the code ready. I'm going just to show how we built it. On the left-hand side here, we see the emulation. So this is a simulation of how the microbit will react to this code. So we see everything is very simple because they are color-coded. So this blue part here, these are the basic elements. So the first block that I'm going to add is this one that is named on start. So I'm going to scroll down the options in blue code and I select here on start. And now we just follow the instructions. So on start means what happens when you start the, the controller. So I'm going to select now another basic function. It's called show string. I just, look how simple it is. I just put it here and we'll click and now it fits. If it's a code that is not available, it won't fit here in this. It's like working with a puzzle. So for instance, if I want to have the forever block here inside, I cannot because it doesn't fit. It doesn't have all these curves. So the colors and shapes of the different blocks, they are very helpful to assemble the parts of the code. So the first thing here is that I want to tell the microcontroller that on start, I want the display on the microbit to display something. So here the default is hello, but I want here to say S because she is the sender. So when I start the button, it will show S, which is exactly what is appearing here. Then we have another element, which is pause. This tells me for how long it will show S. The default here is 1100 microseconds, but I want 1 second, and that is 1000 microseconds. So what it says is that on start, my display on the microbit will show the letter S for 1 second, and then will black out. And then I'm going to turn on its radio. So there's also this block here that is called radio, and I can get this block and put it down here. And this is like the channel. Which channel do you want to transmit your information? We have so many channels, but we are going to be very creative here and use just number one. So it's going to be number one. Yes, okay. So this says that I want my radio to broadcast on channel one, but I can choose any other channel, but then the receiver needs to listen in the same channel. And finally, I have clear screen. So it's a blue code. Where is it? It's here. So I just assembled exactly this code that was already ready here. You see? So it's just to show you how you assemble such code using make code. So it's very, very easy. You may have some difficulty in the start to understand where each function is, but just follow the colors, follow the shapes. It's very intuitive, and then you can build your own code. So that's how I built the first code. I'm going to delete it. Now let's very quickly do the second part. So this is on start. So this is when you start and runs only once. And the forever, it's a loop that will be running as long as the microcontroller is active. So this will be the radio transmission. So you see this is red. Red is radio. So I'm going to select radio. And if here, I want the function that is called radio send value equals. So it is this guy here, radio send value equals. But what do I want to send exactly? So we have two fields here that we need to take care of. First one is name. What is name? Is the name of the variable. So what I'm trying to do now is to tell the radio emitter to send me the acceleration on different axes. So I have three axes. I have the horizontal axis, X. I have the vertical axis, Y, and the other axis that is perpendicular to the other two, that's Z. So I'm going to have three different radio send value blocks, one for each axis. So let's put them here. And I'm calling the first one X, the second one Y, and the third one is Z. But I need to tell what is X, what is Y, and what is Z. It can be anything that the sensor is recording. I want to send the acceleration values. So where is it? It's in input. You see, this is like pink. So this is input, and I'm going to search here. You see there are many inputs that we can transmit. I can, for instance, transmit the light level for a certain variable. I can send temperature. I can send the heading, uh, because these are all values that the microbit sensor can sense. But in this particular case, I'm interested in the acceleration, so I'm going to move this guy here on. Is it like that? Yes, okay, good. So I have now the acceleration as the variable that I'm calling X, and I must be sure that is the acceleration in the corresponding axis. So this is okay, and I need to do the same for the other two axes. So I'm going to select here acceleration again, but now for the axis Y, and finally the same for the axis Z. What I want to highlight here is that if you cannot see, we have two different shapes of inputs. We have inputs that are oval, right? And the input that is has sharp edge for the buttons. So if I want to put this button express it in this variable, I won't be able to, because it's not a kind of variable that is compatible with this type of memory. So if I try to do something that is impossible, it won't work. So this is also very helpful when you are learning how to code here. It prevents you from doing things that are not possible or not usable. So I cannot use this input as a variable. I'm going to delete it. and now select the correct one, the acceleration on Z, and there I have it. Okay, the three variables are set, so the variable X will measure the acceleration on the x-axis, the variable y, acceleration y-axis, and so on. And finally, I'm going to set the initial values for these quantities. So this is where I always struggle. Where is it? It's not on CDO. This is dark blue. Is it on math? Maybe? No. This is one I always get lost here. Maybe it's on CDO. No, this is too dark. It is maybe on, where was it? In extensions. Sorry. I know it's somewhere here. It's in variables, no. Math, no. Logic. You see, you just can go. I found it. It is on LED. So I'm going to, I now remember. So this is not a variable, but this is the position. You see there's one blinking point here. This is the first pixel of the display. So this is x0, y0. If I want to change here, I can change the value, and you probably see the blinking point moving, and we're blinking another point after it displays. As it will blink number 1 and number 2, which is exactly because I changed these values. But we are going to revert it back to 0, 0, which is what the code asks to do. Okay, so now I have coded the second part, which was already prepared, but I just showed you how to assemble the code using maker code. I don't need it, so I'm going to delete it. Now, this is all the code that I need for the sender. So after it is recorded, what I need to do, I need to upload this code to the microbit. So that's what I'm going to do now. Yes, if you can turn on your camera again, Luis, that will be helpful. Luis is turning it on now. And what we are going to do is to precisely use I'm going to stop sharing also because then people can see it better. Stop sharing. Yes. So this is the microbits controller. We need to connect it to the computer. So this is the USB cable that comes with it. It has a micro USB connector that connects here. Okay, so it's connected, and now I'm going to connect it to my computer. If I can find the adapter, yes, it's here. So I'm going to connect it and connect it to my USB port on my computer. It is connected. I'm going to share again. So Luis very skillfully is showing to you this, and now going back to the presentation. Yeah, I was here. Okay, so now I have the microbit connected to my computer. The lights are blinking, and I know it's powered. So the first thing here is I need to tell the computer that I want to connect the microbit to the make code environment. So you see here you have the two miniatures of the microbit. We have this option download, but don't click there. You need to click on these three dots to the right of the download button, and I'll tell the computer to connect to the microbit. So it's telling me that you need to connect to the computer. It's already connected. And then it has the second message that if you click on pair, there will be a window appearing, which is this one. And I'm going to connect. And now it's pairing the microbit to my computer. They are connected. And now I can upload the code. Actually, the wording here, they prefer to use it download. So the microbit will download the code that is in my computer. Or if you prefer, I'm uploading the code to the microbit, doesn't matter. After you connect, you pair the device, I just click here, download, and you transfer the code from my computer that we just coded together to the microcontroller. It takes a few seconds, and after that, it will be ready. And the first part of my coding is complete. Yes, it's done. And I can start using the sender as soon as we are finished with the second part. So now what I will do is I will disconnect and eject, and I don't touch that microbit again until we are using it. So I'm now going to eject from my computer safely. Eject the microbit. And it will be ejected. It is ejected. I can safely remove it. Okay, and leave it here. Don't touch it again, Luis, because this is the set that I don't want to have a confusion. Okay, so that was the coding for the sender, and that was the easy one. What you need to code now is the receiver. So that microbit that we just coded, it's going to measure the acceleration in the three-axis, and will send the values of the acceleration for the receiver, which is the second microbit that we are going to show how to code. This is a very long code, so I'm not going to do step by step. Instead, I'm going to show the full thing and just comment the important parts. First things first, get back to the presentation, and then I'm going to move back to the make code environment. So this is just what we just finished it. So sending the code to the microbit. After we do that, we need to create a second project that is the receiver. And here we are going to use a few more groups of functions. In particular, we need an extension. So these are additional modules, and we are using data logger. This is an extension that is required to store all the information that the receiver will get from the sender. So it's very easy. You just go to extensions, type data logger, and install it, and it'll be added to your list of modules. So here we are going to use several different modules at the same time. Luckily, they are all color-coded. So we already seen the blue group, which is the basic one. We already seen the red-pink group, which is the radio. We have some additional modules here. This is the input. We saw that also. And now we have this green. This is the data logger. So that was the extension that I added. I'm going back here. And we also need some functions that are called serial. These are for storing the data in the memory. I'm going to show the full code in a bit. It's just to show you the necessary steps. So here I think we have 4 different blocks of code, but this is very detailed in the course. You have this document that you can follow step by step, and you can do it with attention, and you'll be able to code. Once you do it correctly, it will work. And the final result is this. So we have the center here on the left, which is we finished a few minutes ago. And here is the receiver part. I'm going back to the Maker Code platform because I want to show you the second code and make a few comments that are important before we transfer the code to the second microbit and do the experiment. So sharing again now, make code for this final part of the webinar. Maybe a 10 minutes more and I'll be finished. So this is the window that I want to share. So this is the sender code that we just coded together. Now I'm going to select receiver. So this is the receiver code. In fact, these are 6 different pieces of code. Let's just briefly comment one by one. So this first one is very similar to the sender. You remember I wanted to, on start, to have letter S on sender. This one is letter R. So we know this is the microbit that is the receiver. And I want that letter to display for 1 second. I want the radio transmitter and receiver to be in the same channel. So it's the group 1. So it must be the same channel. And I ask it is different. I want 3 columns called X, Y, and Z that will receive the correspondent data from the sender. So this is the start part. This second block is just to clear the memory. So the microbit has 2 buttons on the front. It's called button A and button B. So here is just something that I coded to empty the memory buffer. So whenever I press both buttons at the same time, button A and button B, it will delete all data that is stored on the receiver. That must be clear. And it will display this check mark, so I know it has been deleted. This one in the middle I'll address at the end. And we have another 2 very short blocks. This one is to clear screen. It just tell you that if I press the microbit logo button, which is this yellow one, it will erase the display. And this green one is to let me know when the memory buffer is full. So if the memory for the microbit is I cannot store any more data, it will start displaying full on the main display. So these are like accessory. The main action happens here in this big chunk, which tells me exactly that if I receive the data from the sender, it will store the data accordingly in the correct variable. And not only that, but will display me the intensity of the shaking on the display. So there are some things here that are important that I will use this button here that is called radio. And particularly, we have radio receive name value. So this is the block that starts all this section. And you see here that we have 2 red uh, variables that are called name and value. Why this is important? Because if I want to code these other blocks here, for instance, the serial block, which is serial write value, where is it? Serial write value, yes, this one. So this is the one that I need to put it here. But you see that by default, it comes with X and O. And here on the code is name and value. How I do that? How do I change? Do I need to type name and value? No, because you see for these other ones, the content is white. This means that you actually need to type it or use the sliders to set the value. But when it's red, that means that you need to select the variable here from the radio function and bring it to the bottom. So this is really the most delicate part, that when you are following the step-by-step instructions, sometimes people get lost here because they think they need to type, and it's not like that. They really need to select here the kind of information that was received by the radio and bring it to the appropriate variable. So that's how it works. And you see all the other fields here that are in red. You need to do this. You need to bring it, be it name or value, and drag it until the correspondent field. If you do that, you will be able to conclude this coding. What it does essentially is to display different values here of acceleration. So the most intense accelerations will light a certain number of pixels here on the LED for the microbit. Okay, so as I said, we don't have, we need to finish the webinar in a few minutes, so I'm not going to code it step by step, but you already know how to do it. What I need to do now is, again, transfer the code to this second microbit. I'm going to do it again, and we're going to show it. It's just like I did for the first one. I connect the USB adapter to the microbit, and then connect it to my computer. The lights are on. Okay, so what I'm going to do now is, again, connect the device. Is already connected, and I'm going to transfer the code from my computer to the microbit. And once it's ready, I can start immediately working. There's only one more thing that we need to do, and my seismometer will be ready. We are finishing copying the code. Luis is okay. So the code is all now. My receiver is ready to receive the data from the sender. The only thing that is missing now is that I need power for the sender. And for this, we are going to use this guy here. So this is the battery pack for the microbit. It has a connector. It's not a USB connector, but it's a standard power connector for the electronics that we can plug it on this part here, on the right, on the left. No, right. Yes. And when I do that, you see it turns power immediately. I saw the S, and now it's already transferring the information to the receiver. So what to see this in action in my make code environment, I have this option that is show data device. When I click it, I have a real-time graph of the transmission. It's a bit shaky, but now if I pick it up, I can now, if I'm moving, up and down, can you see? Up and down, the acceleration, positive, negative, on one axis. Now on the other axis, it's not showing. So 1, 2, 3, and this one, yes, back and forth. It gives me a different direction. I can also put it on the table and we will stabilize, and now we can try to turn on the motor. Where is here it is. I just need to plug it in. Oh my God, that's not ready. Anyway, if I start tapping here on the microbit, oh, it was disconnected. Sorry, I had an accident here. I have to connect again. It was ejected. Okay, it's back. So if I start, clapping here on the table, it records the vibrations and I'll stop it. So imagine we are here in Portugal. Hopefully, thankfully, there are not many earthquakes here, but sometimes they happen. And if by chance there's an earthquake here and starts some shaking on the table, the sensor will record this vibration and it will transmit. And I see here is the data in real time from the sensor. So this is how it works. I think it's a very interesting activity to have your students. You can do it when you're, for instance, teaching them seismology in geology class or in physics or in science. And then you can not only they understand what is an earthquake, but also how you can build using 2 microbits. Can build a very simple sensor that will show in real time the movement, the acceleration of each one of the sensors. And they will learn coding and they will have fun because they will be using the Make Code platform. And there's so much else you can do using not only microbits but Arduinos, and these are all detailed in the robotics encoding GeoConcept section of the GeoBServe platform in the e-modules. So I think this completes this presentation. I think I don't know if you enjoyed it. Shanna, have you ever heard of microbits before?
No, it was the first time. It's super interesting and super clear also for me. So thank you very much, Gustavo. And Luis,
Okay.
too.
Yes, Louis is also very helpful here. Thank you for being my assistant.
It was not the first time, but it was super interesting. And thank you for the activities, of course, the interactive presentation and all the effort you both put into the demonstration. I think it will be really interesting for the teachers, for geo-related activities. So yeah, it's a gift for GEO-Academy.
Yes, and this presentation, this webinar will be available on the GeoBServe platform as well, on the new session, so you can watch it again. And of course, the step-by-step guide is also available on the platform. So I think we reached the end. So we have an additional webinar, right, Shanna? But it is yet to be announced. But we will meet for one final time in this series of webinars.
Exactly.
Yeah. Thank you very much.
Gustavo and Luis, thank you very much. Shanna, thank you once again for organizing everything. Also, Aphrodite, thank you for joining.
Yeah.
And we stay in contact and we stay tuned for the next webinar. And of course, the conference in Paris.
Yes.
Shanna, send me the link for tomorrow.
Yes. Yeah. I will do. Thank you very much. Bye.
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 Thank you.